Alright, and this video is going to talk about another method that we could utilize to find some limits. So you might remember that we discussed different coordinate systems in the beginning of the semester. Well, we can actually use those to our advantage and try and use those to help us find the values of different limits in multivariable calculus. Okay, so remember we have polar, we have cylindrical, pretty much the same thing, just depending on if we're in 2 or 3 dimensions, and then we also have spherical. Okay, one thing to keep in mind that as we change the coordinate systems, we have to change the limits as well, right? So that if we're, say, approaching that 0 vector, right, in R2, then really the R value that we have is going to be approaching 0 from the right-hand side. We can't approach 0 from the left-hand side because we're zooming in towards that 0 vector, okay? This, however, does not mean that theta approaches 0, okay? That's not necessarily the case, okay? I'll also just say that if you look at rho, this is similar. Okay, so when you're if you change the spherical coordinates at all, just keep that in mind. Okay, first example we're going to do, you're going to look at it, you're going to say, well, Professor Bright, why do we even need it? Well, to get experience, right? So you can look at this and say, well, 0 times 0 is 0. Great. Okay, let's see it a different way. If I change this to polar, okay, so instead of looking at x is approaching 0, I'm looking at the limit as we approach 0 from the right with r, and I get r squared cosine theta, sine theta, okay, and again, I did a little bit of algebra there. I'll let you pause the video and catch up if you need to, okay? But really what I'm saying at the end of the day is that, well, if I'm looking at 0 from the right-hand side of all this for r, this is just going to be 0, right? As I decrease r towards 0, the whole quantity is going to approach 0 no matter what. Okay, so that can help us kind of reaffirm that yes, 0 is the correct limit for this function. Great, so we actually found a limit that exists. Let's see about another one. Okay, yes, big, long, complicated expression. I'm not going to say it out loud, you can write it down. Okay, for this one, let's just see if cylindrical coordinates or polar coordinates are going to help us in solving this. Okay, so let's see, I'll have the limit as r approaches 0 from the right. Okay, and I get r to the 5th, and I'm going to write c to the 5th instead of writing cosine for everything, so c to the 5th, and then plus r to the 4th, s to the 4th, sine, okay, sine to the 4th, minus 3r to the 3rd, cosine to the 3rd, actually this would be cosine, or r to the 4th, when we incorporate the y as sine, right, and then plus 2r squared cosine squared plus 2r squared sine squared all over r squared. It would be r squared plus cosine squared, and then another r squared plus cosine squared, factor out the r squared, and yep, you get it. Okay, and then we can simplify, right? Take out, oops, let's try that again. Take out an r squared from each and every term. Okay, and let's see what I'm left with. Okay, so at the end of the day, what is left? Limit as r approaches the 0 from the right side of, and then I get, let's see, parentheses, r to the 3rd, cosine to the 5th, plus r squared sine to the 4th, minus 3, oops, try that again, 3 r squared cosine squared, sine squared. And I should also mention here we have cosine squared plus sine squared, right? So that's just plus 1. Okay, well, this is really nice, right? Because now I'm actually going to send r to 0, which, okay, that goes to 0, that goes to 0, that goes to 0, and I'm left with 1. Hey, look, that actually made my life a lot easier, okay? And it's actually a lot faster than maybe, say, typing it into Wolfram Alpha Pro or Calcplot 3D, etc., etc. So actually, polar coordinates helped us find a multivariable limit. Okay, and so now we've kind of used up our main tools of the intuitive definition and this idea of changing coordinates, and in the next video we're actually going to do some limits formally.